We are solving logarithmic equations today. We solved exponentials yesterday, and we're going to use some of the same processes because we are going to have to change these to exponentials. So one of the things we may have to do on these is to condense the logarithm, which is what we did the other day, so hopefully you actually practiced on it. And we have to isolate it, which means we have to get it all by itself. Once we condense and isolate, we rewrite it in exponential form, which we know how to do. Then we have to solve, and this is important here, check for extraneous solutions. So let's talk about what that means. That means we're going to solve this, and we'll get an answer or more than one answer for x. It may be that one of the answers we get, or all of the answers we get, maybe none of them work. And so we have to understand what it means and how we know if they work or not. We did not graph logarithmic functions. So I'm going to show you a parent function of a log so you can kind of understand what we have to deal with here. So a parent function of a log would look like this. The exponentials have horizontal asymptotes. The logs for the parent function has a vertical asymptote. And then the log looks like this. Okay? So if we said this is f of x equals log, we'll just make it log base 10, so just log of x, right? That's basically what that parent function looks like. So what we know here then is that the domain, is the domain all real numbers? No. The domain starts at 0. Do we get to include 0? No, because there's an asymptote there. To infinity. The range is negative infinity to infinity. Since we are solving for x, x is part of our domain. And we don't get to use just any old x. Now, that doesn't mean that the x that we get has to be between 0 and infinity. That means that whatever we take the log of has to be between 0 and infinity. Because if this is my parent function, then clearly I can't take the log of 0 and I can't take the log of a negative number. Does that make sense to you? So when we check, we're going to get an answer instead of just getting an answer and being like, woohoo, we're done and moving on. We're going to get our answer. We're going to substitute it back in and see if we don't have to like substitute it and do a bunch of work. We just would have to substitute it in here and make sure after we multiply by 3 and subtract 4 that whatever that value is would be greater than 0, then we're good. Okay, so we have to actually check our answers here. So let's see how this works on number 1. So it told me I needed to condense and isolate the logarithm. Well, it's already condensed and it's already isolated. Isolated means that it's the only thing on one side of the equal sign, so we're good. So all we have to do now is rewrite it in exponential form. The base of the log, remember, is the base of my exponent. I take it to that power, which is 7, go around the equal sign, that's equal to 3x minus 4. Then it's just a simple algebraic equation. So we're going to do 2 to the 7th. We can count on our fingers, right? 2 times 2 is 4, then 8, 16, 32, 64, then what? 128. So 2 to the 7th is 128. That's equal to 3x minus 4. So I will add 4 to both. I get 132 equals 3x. And I'll let you use a calculator on your assignment, but I'm going to make you think on the notes. It's 132 divided by 3. Try again. Really quick. 44. There you go. X is 44. All right. Now, when we check this, when we substitute it in, we don't have to actually multiply and find the numbers. I think you can tell without actually multiplying that if you substituted this in here and you multiply 3 times 44 and subtract 4, will that answer be positive? Yes. So, excuse me, that means we'll take the log of a positive number. This is my answer. Okay? We okay with that? All right. Good deal. Let's try number 2. So my log is condensed and it's isolated, it's all by itself, so I just have to rewrite it. What is the base of this log? You remember? Natural log has a base of e. Very good. So even though it's not, you don't see it there, the base is e, so I take e to the 9th power, and that's equal to 2a. Right. So I am solving for a, so I just need to divide both sides by 2. So e to the 9th divided by 2 equals a. That's my answer. Okay, I want it in exact form. I don't want it to be, you know, anything crazy with decimals. So then I have to verify my answer or check for extraneous solutions. I substitute this back in. Well, if I double, first of all, is this value right here going to be positive? Because e is a positive number, right? So this is positive. If all I'm doing is multiplying it by 2, is it still positive? Yeah, so then I'm good. Like, you don't have to actually work things out. It's fine. We good? Awesome. All right, so we're going to jump to number 4. So remember, I have to first condense and isolate. So I have a log and I have this right here. So I think I want to go ahead and subtract this. So I'm going to subtract 4 from both sides. So that gives me 2 times the log base 9 of k squared plus 2k equals 1. Now I have 2 options for that 2. Could I take this 2 and make it an exponent up here? Remember that exponent rule? I could do that. But I don't know that I really want to square that. That's kind of yucky. My other option is just algebraically, since this is the only thing over here, I could go ahead and divide both sides by 2 so that I get log base 9 of k squared plus 2k equals 1/2. But what I couldn't do, because I see this mistake a lot, I couldn't divide at this step and just divide both sides by 2 because I had something else over here. The reason I can do it now is because that's the only thing that has multiplication on it, right? Okay, so now my log is condensed and isolated. So now I rewrite it in exponential form. The base is 9. So 9 to the 1/2 power is equal to k squared plus 2k. What is 9 to the 1/2 power? 3, because anything to the 1/2 power just means the square root, right? So this gives me 3 equals k squared plus 2k. This is a quadratic. Anytime you see a quadratic, your first instinct should be to set it equal to 0. Your second instinct should be to factor, because sometimes our first instinct is to factor, but you don't want to factor right here. We set it equal to 0. So 0 equals k squared plus 2k minus 3. And I've kind of run out of room, and we're not doing number 3, so I'm going to move my work up here. So go ahead and factor it, because I know that you can, and solve for k. Factor it, I'm going to come thump you in the head. +3, -1, right? Which means that k is equal to, now I have 2 answers, so I'm going to put them in a set. I've got a 1, well, let me do my -3 first. Got -3 and 1. But then I have to check them, and I have to check them both, okay? So when I put -3 in here, I square it, that becomes a +9 plus a -6, so that's still positive, so my -3 works. And 1, when I put it in there, it'll all work, so all is well, and I have 2 answers. What questions you got? We good? All right, let's look at number 5. So I have to condense and isolate my logarithm, which means I have to put this together. I have 2 logs with the same base that are being added, right? So I can condense them into 1 log, and what do I do with these 2 pieces? Remember, when I add 2 logs with the same base, it becomes 1 log, and the addition goes with multiplication, right? Did you all actually practice these things? Okay, so I'll have log base 4 of 2v plus 3. Oh, no, what is my computer's locking up a little bit. Okay, times 2v minus 3 equals 2. Right, so now inside of here, I need to actually multiply them. That is a special case that is called what? Come on, it came up a few times the other day. Y'all know this. Difference of what? Squares. If you have the 2 things, these 2 things are the same, 1's plus 1's minus, it's just a difference of squares. So I'm going to have a log base 4. That means I square the first one, which would give me 4v squared, minus square the second one, which is 9. And that's equal to 2. Now rewrite this in exponential form. The base of the log, the base of the exponent. So write down your 4. Where do you get the exponent for that? What does that equal? Yep. Good. Beautiful. When you rewrite an exponential form, this is the base, this is the exponent. Does that make sense? So we're going to do, we're just rewriting it first, we're going to do 4 to the second power equals this right here, which is 4v squared minus 9. Okay. That gives me 16 equals 4v squared minus 9. That's a quadratic. Your first instinct should be to set it equal to 0. So I'm going to set it equal to 0, and that's going to give me 0 equals 4v squared minus 25. Your second instinct for a quadratic should be to factor. Can you factor that? What is this thing called? Difference of squares. Good. 0 equals, I'd have 2v plus 5 times 2v minus 5. Trust me, you'll like that better than having to take the square root of a fraction, even though that's not necessarily difficult. So when I get this, even though we can say, right over here, that we could use plus or minus, I'm not going to, since we have to check both. It's kind of better sometimes if they're split. So I'd have a negative 5/2 and a positive 5/2. That way I can check them both separately. So when I check these, I'm going to take this negative 5/2. When I put it in right here, negative 5/2 times 2 is a negative 5 plus 3 gives me a negative number here. Is that okay? That's not okay, right? That means this one doesn't work. I still have to check the next one because it's possible that neither one of them work. So when I put this in here, that's a positive 5 plus 3, so that's fine. Put it in here, this would be a positive 5 minus 3, that's still okay. So my answer really is just 5/2. Okay, everybody okay with that? All right, good deal. So let's look at number 6. Number 6, I have a fraction bar that disappeared again, right there. And I have this exponent. Now I can't just multiply both sides by 3, make this go away and make this 12 because I have something else going on here. But I can go ahead and make this an exponent on the 27 because I think that would actually be most helpful. So when I do that, taking anything to the 1/3 power is the same as doing what? What does the 1/3 power mean? Cube root. So if I have 27 to the 1/3 power, it's the same as the cube root of 27, right? So what is the cube root of 27? 3, good. So I'm going to go ahead and rewrite this as the natural log of 3 plus the natural log of x minus 5 equals 4. I cannot rewrite it as an exponential right now because I still have to condense these. I'm adding two logs that have the same base, so that becomes 1 log, and what do I do with these two things? Multiply them. So I'm going to go ahead and multiply it out. That'll give me 3x minus 15. And then these parentheses are important. Otherwise, it would just look like the natural log of 3x, and then we subtract 15. That's something different. This equals 4. Okay. So now that I have it isolated and condensed, I'm going to rewrite it in exponential form. What's the base of this? E. Good. So this would be e to what power? The 4th. Good. Equals 3x minus 15. And I'm solving for x. This might look like it's way more complicated than the others, but it's really not. It's the same steps. I'm going to start by adding 15 to both sides. So I get e to the 4th plus 15 equals 3x. To get x by itself, I'm just going to divide both sides by 3. So I get e to the 4th plus 15 over 3 equals x. And I understand that you don't have a good concept of what that value is right now, but that's okay. That's your answer. It looks weird. Sometimes our answers look weird. But I still have to check it. So when I substitute this back in, there's nothing to substitute back in here. I just need this. And I just need this to be positive, which means I need x to be bigger than 5. Yes? So if you just ignore this e to the 4th, first of all, this is just some positive number, right? If I just look at this part, 15 divided by 3 is 5, right? If I add anything to 15 before I divide, will this number be bigger than 5? Then that's all we care about. So you can just kind of reason through it. You don't have to actually come up with a value. So this is my answer. We okay with that? Okay, so when you condense and isolate, if you just have a log equal to a number, this is what you do. We could end up with a log on both sides. That's what comes next. Oh no, I jumped ahead of myself here. That comes down here. It's almost next. Let's see, was I going to do both of these? Yeah, we'll do both of these. Okay, so if I'm going to condense this, I have 2 logs, same base. What do I do with these 2 pieces? Multiply. So I will have log base 2 of n minus 3 times n plus 1, and that's equal to 5. So I need to actually multiply these. These are not a difference of squares. So I'm going to give you a minute. I want you to actually multiply them. However you go about multiplying them, there's different ways, but we're going to make sure we all get the right answer. Do it. Very good. Very good. Making me proud. Stressing Daniel out over here. That was right. Don't erase that. Keep going. Well, whether or not that's right depends on the rest of what you write, so you got to finish. Are you finished? You're finished, I'm going to thump you in the head. Tell me what you did to get that number. Okay, that's fine. But what about the n times 1 and the negative 3 times n? See, part of the problem is I don't know how you learned this. That's why I said however, like whether you're going to FOIL it or it's the box method or it's distribution, like there's all kinds of different ways. Okay, does that make sense? So if I do negative 3 times n is negative 3, n times 1 is 1. You put them together, that's going to give you a negative 2n. And then you do the negative 3 times 1. Does that make sense? Okay. So if you're going to FOIL it, or again, whatever you do, n times n is n squared. Then n times 1 is n, negative 3 times n is negative 3. Together that gives you a negative 2n, and then minus 3. That's equal to 5. All right. We all good on that then? Rewrite it in exponential form. Yes, sir. Oh my goodness. You need to be able to multiply too. It better be fast water. All right, so I get 2 to the 5th equals n squared minus 2n minus 3. What's 2 to the 5th? 32. Very good. So we get 32 equals n squared minus 2n minus 3. Then I want you to set it equal to 0, factor it, solve it, check your answers. Give you a second to get that done. You agree with that? When you factor it and solve it. Then check for extraneous solutions. Is the negative 5 going to work? No, because when I put it in there, I get a negative 8, so that's bad. 7, when I put it in here, I get 4, and you have to check both of them, and 7 plus 1, that's good. So your answer then is just n equals 7. Okay, we're good? Awesome. So let's look at number 8. Number 8, we're going to have to condense, but there's subtraction. So when I have 2 logs at the same base and I condense them, I get log base 2, and what do I do with these two things? Divide. This will become c squared over 3c minus 5, and that's equal to 2. So now that I have it condensed and isolated, I'm going to rewrite it in exponential form. That would become 2 to the second power equals c squared over 3c minus 5. All right, what's 2 squared? 4. Okay, so I'm going to write 4 equals c squared over 3c minus 5. I would like to get rid of my fraction, so I'm going to multiply both sides by the denominator. And when I multiply this by 4, I'm going to go ahead and distribute. Okay, so that's going to give me 12c minus 20 equals c squared. Once again, I get a quadratic, so my first instinct should be set it equal to 0 and then factor. So since I would like to keep c squared positive, I'd move everything over to the right. Okay, so go ahead, finish it up, check your answer, see what you think. So do we agree with what I got for C here? Then when I check them, regardless of what I put in here, since I'm squaring it, that'll be positive, that's fine. And then if I double 3 and subtract 5, I'm good. Same with 10, so both of them work. That's my answers. Okay, we good with that? Any questions at all? All right. So now, what I was saying before we get to this page is that we could end up with a log on both sides. So our steps are pretty much the same. We have to condense the logarithms and you have to isolate them on each side. Then we use the one-to-one property. This is similar to the one-to-one property for exponentials. If I have log base b of x equals log base b of y, basically two logs that are equal that have the same base, then their arguments have to be equal. X has to equal y. And then you solve and once again check for extraneous solutions. So on number 9, I do just have a single log on each side, but this 1/2 has got to be taken care of first. So it can become an exponent on this whole thing right here. That's why those parentheses are important. So this means I get log base 4 of 4p plus 3 equals log base 4. Taking something to the 1/2 power is the same as taking the square root. So that would be the square root of 16p to the 4th. Okay, we good with that? So now I have two logs with the same base that are equal. So now I can just set these two pieces equal to each other. So the left is 4p plus 3. I'm going to go ahead and take the square root of 16p to the 4th. That would be 4 times p what? Squared. Very good. Guess what? We got a quadratic again. So we got to set it equal to 0 and factor. So 0 equals 4p squared minus 4p minus 3. A is not 1, so we're going to have to factor how? By grouping, right? Okay, so I'm going to give you a minute to dig that out of the back of your brain. See if you can factor by grouping, then I will walk you through it. So remember, I need two numbers that are going to, that means the signs are opposite, so they're going to have to subtract to give me -4. And that's 2 and 6, and it would be a +2 and a -6. Whichever order you put these in would be fine. That's what you get right there. Again, it could be the other way. Then we factor by grouping, so I would factor out a 2p. That leaves me with 2p plus 1. Here I would factor out a -3, which leaves me with 2p plus 1. So in the end, I get 2p minus 3 times 2p plus 1, which if you had flipped these around, you'll have the same answer right there. It just looks a little bit different for a minute. We can all factor, right? Got to be able to factor. All right, so then p is going to equal a -1/2 and a +3/2. Then I have to check them. When I put -1/2 in here, 4 times -1/2 is -2, plus 3 is fine. And then negative in here, it's to the 4th power, so it'd be positive, so it's totally fine. And then 3/2, if everything's positive, it's all going to be fine, and this is my answer. Okay? We good? All right. Let's look at number 10. So I have 2 logs over here. I only have 1 over here, but I have this out front. So I do need this to become an exponent. I can't make this an exponent until I combine these, or I'd have to distribute it. I don't think I want to distribute it. I think I'd like to combine them first. So this, on the left, I'd get the natural log of a plus 1 squared equals 3/2 times the natural log of 80 divided by 5. Okay. What is 80 divided by 5? 5 goes into 8 once, with 3 left over, 16. So I'm just going to mark that out and change it to 16 instead of rewriting things. That's totally fine. So then this 3/2 is going to become an exponent on the 16. 3/2 is the same as 3 times 1/2. Do you agree with that? So the 1/2 is like a square root, and the 3 is like to the 3rd power. So when we go do this, let's go on this left-hand side. This right here, I want to actually square it out. When I do that, the answer is not a squared plus 1. We know that much, right? It becomes a trinomial. So it's a squared plus 2a, because you multiply these two together and you double it, plus 1. And if you don't know the pattern to get there, then FOIL it or do whatever you got to do. Just make sure you get it right. That's equal to the natural log of 16. Okay, so we just said it's to the 3/2 power. So that 1/2 is the square root, and the cube is a cube. So we're going to take the cube root, and then we'll square it. I'm sorry, we'll take the square root, and then we'll cube it. Totally said that wrong. Square root, and then cube it. You could cube 16 and then take the square root, but that makes your number a lot bigger. I'd always reduce it first. But at this step, I have 2 logs that have the same base that are equal. I can drop the log part and just have this. So this would give me a squared plus 2a plus 1 equals just the square root of 16 cubed. So let's think about that over here. The square root of 16 cubed equals, what's the square root of 16? 4. So then that's just 4 cubed, and what's 4 cubed? 64. Okay, so 16 to the 3/2 power is just 64. We have a quadratic. We're going to set it equal to 0. We're going to factor it, solve it, finish this problem on your own. You know what is very helpful when you're factoring? Knowing your multiplication facts, right? It's got to know 2 numbers that multiply to give me 63 and would subtract to give me 2. It's going to be a positive 9 and a negative 7. So when we get these, do they both work? Nope, because when I put in negative 9 here, that makes that a negative, so that one doesn't work. Take 7, put it in here, that's fine there, and then there's no x's over here, so my answer then is just a equals 7. What questions you got? We good? You can do this, but you got to be able to factor, and you got to be able to condense your logs easily. We good? All righty.